anyone join? Okay, let us wait 5 minutes.
इससे पहले कि वो चांद
Hello? Hello?
Kima.
Hello, I am audible. Please just confirm. Hello? Please just confirm whether I am audible or not. You are visible, but your audio is not. Hello? Hello, you can write in the chat box also. Hello? Hello? Please just unmute, then you talk. Just unmute your. Just you turn on your microphone symbol. Just you turn on, then you can, I think, able to speak. You can write in the chat box whether I'm audible or not, or the screen is visible or not. Oh, you are not able to hear me? Oh, very less. So you just what you can do, you just rejoin. Just leave the class and rejoin. Just please try to rejoin. Hopefully it will work. So from my side, I think everything is okay, no problem. Let me just check. Hello? Yeah, it's audible. Hello? Yeah, it's very sound. So from my side, everything is okay. I have just checked. I think problem from your side. So you just please try to do. You just increase your volume of your mobile, or you can do one thing more. You just leave the class and rejoin. Then hopefully your mobile will work. You can do these two things. Okay, no issue. So we can start the class also. No problem. So today is the week 4, and we'll discuss about the this your topic is fluid dynamics again, the application of conservation of momentum and the Bernoulli's equation, and third one is the application of Bernoulli's equation. So here we look the application for conservation of momentum and Bernoulli's equation, and what is Bernoulli's equation also. So this question, actually the first, I have lot of question for today, but these question are from your previous whatever I have taught in the previous fluid mechanics in 2024-23. That questions also I have written here. I have put it in this slide. So once I'll upload this question, you can go through one by one. So let us start with the new questions. For 2025 I have collected the new questions. Yes, so the previous class was also about your fluid dynamics. So here what I have did, here I have done the summary of whatever I have covered in the previous classes, that is week 1, 2, 3. So that questions I have also involved in this week, that is the week number 4. So I have collected the question from this week as well as your previous week. So let us begin with the first question for today. So first question is, this is from your week number 1. So in fluid shear stress, tau is, this is tau is this, the written is like that, del u by del y power n. If exponent, if n is greater than 1, then the fluid is whether the pseudoplastic or Newtonian fluid, dilatant fluid or Bingham plastic fluid. So please you write your answer in the chat box, which option is correct based on your understanding of your previous week as well as your this question from your first week. So please, based on your understanding, you just try to give the answer which option is correct, whether A, B, C, D. So I am waiting. You can write in the chat box. So which option is correct? You can just think and try to write your answer. Very easy question. Okay, so for the answer for this question is your dilatant fluid. If your equation is like that, when n is greater than 1, so definitely it will be the dilatant fluid. So remember please. And here the definition of, for your Newtonian fluid, for Newtonian fluid this n will be equal to 1. Once n will equal to 1, the equation will be like that, mu del u by del y. So this formula relates the Newton's law of viscosity or Newtonian fluid. And for non-Newtonian fluid, if n is less than 1 or greater than 1, we use for non-Newtonian fluid. So here the final, the graph is there for different fluid. Dilatant fluid, if greater than 1 dilatant, less than 1 is pseudoplastic, and is equal to 1 then Newtonian. Remember please. Let us move with the, and here a lot of definition is there. What is ideal fluid and what is real fluid, Newtonian fluid, non-Newtonian fluid, pseudoplastic, dilatant, and ideal plastic or Bingham plastic you can say, and the rheopactic, thixotropic, and the viscoelastic fluid. So lot of definition here is written. So once I'll upload this PDF, please go one by one. This is very important as per your fluid mechanics point of view. So now this question from your fluid dynamic, the question is, in hydraulic grade, the hydraulic grade line for flow in a pipe is constant. Sorry, the hydraulic grade line for flow in a pipe of constant internal diameter. That is, your pipe is prismatic, there is no change. If the diameter here is D, here is also D, here is also D, and here is also D. Everywhere D. D means if here is 1 meter, then here is also 1 meter, 1 meter, 1 meter, everywhere. So now the option is coincide with the hydraulic gradient line for for a prismatic your pipe coincide with the physical center line of the pipe, is always above the center line of the pipe, is always sloping down in the direction of flow, is always above the total energy grade line. Which option will be correct? So please, based on your understanding, you just try to write your answer in the chat box. As such type of question I have already discussed in the previous class also, week number 3. So definitely I want answer from your side, please. If you have gone through the video or from previous lectures, so definitely you are able to give the answer. So I am waiting. I'll wait 1 minute. Then after I'll show the answer. So please just try to give your answer. So please, if you know, you can write your answer in the chat box. Okay, let us discuss. So here hydraulic gradient line we are talking about. So let me just show you the answer, then I will show you. So it is always sloping down in the direction of flow. So first, what is hydraulic gradient line? Here is the figure is given. What is your hydraulic gradient line? This is. So first of all, try to understand what is hydraulic gradient. What hydraulic gradient line represent? So basically hydraulic gradient line is your combination of both your pressure head plus your datum head. Pressure plus datum, and total energy line is your hydraulic gradient line plus your velocity head. Means pressure head, datum head plus velocity head is combinedly known as total energy line. That is, if you will draw at 2 or 3 points these combined relationship, then whatever you will get the line after joining these all point, so you will get the hydraulic gradient line, as you can see here, hydraulic gradient line and total energy line. So it is, here you can see it is downfall, or the question was, the answer was, is always sloping down in the direction of flow. Why sloping down? Why sloping down? Because of the friction or resistance, you can say, resistance of the flow due to the internal friction. Due to the internal friction of your pipe. So this is about the previous question. Now let us move on the next question. So next question is, yes, what are the dimension of Manning's constant? So this question is from your, also you can say from very beginning. This is what is Manning constant. I think once you will go in the open channel, then you can get. So let us leave this question. So Okay, by the way, I have given the formula as well as the your answer. But let us move. The previous question was about from your coming weeks, the week number maybe when you will study the open channel flow. So now let us move with the next question, whatever you have already studied. So the next question is, to which of the following condition can be the Bernoulli's equation between any 2 points be applied? The question is, to which of the following condition can the Bernoulli equation between any 2 points be applied? So in which condition we can apply the Bernoulli's equation at 2 points? Whether the flow is any rotational flow, rotational of an incompressible fluid, steady irrotational flow of incompressible fluid, steady rotational flow of incompressible fluid. So which option will be correct? A, B, C, D. Which option will be correct? You can write your answer in the chat box, please. Whether A, B, which option will be correct? You can write your answer. Whatever you know, whatever you have learned from the previous classes. So please just try to write your answer in the chat box. Which option will be correct? So while deriving your Bernoulli's equation, we assume the assumption, we assume this, the C number assumption. The fluid should be steady, irrotational and incompressible. Steady means your change in flow parameter, let us assume the velocity, not should not change with respect to time. Flow is irrotational, there is no rotation in the fluid. Fluid is incompressible, that is no change in density from one, as your fluid move from one place to another place. So remember please. Now let us move with the next question. Here is the explanation is given very well with the pictorial representation. Everything is given, I have included here. So please you go one by one, you will definitely get insight. This is from very basic question. If the power developed by turbine is 2 to 0.65 kilowatt, so this is just your conversion. What will be the power produced in metric horsepower? So you have power in kilowatt, you need to convert the power in metric horsepower. Just here is the unit conversion. If you know about the metric horsepower, you are able, definitely you will be able to convert. So option A is 300, B is 200, C is your 100 and D option is 400. So which option will be correct? You need to just here unit conversion. Remember please. So let me just show you the answer because this is not more relevant. So here you can see the different definition of horsepower. First one is mechanical horsepower is 145.7 watt. Metric horsepower is 735.498, you can see, and electric horsepower is 146 watt. Means one electric horsepower is 146 watt. One mechanical horsepower is 745.7, almost equal. Another one metric horsepower is 735.498. So means you can write this one also 4746, you can write this one 736. So difference is 10, as you can see from your electric horsepower. So difference is 10. So this is not relevant from your this week. So but remember please. Okay, now the question is very very important. Find a actual discharge and the actual velocity. Here you need to find actual velocity, discharge and velocity of the flow through an orifice 100 mm diameter discharging water under head 10 meters. So head is given 10 meter and the diameter is of orifice is given 100 mm. Now take coefficient of discharge is 0.66 and coefficient of velocity is 0.96. So you have to find here actual discharge and actual velocity. Two things you need to find out here. So please just try to write your answer in the chat box, or you can turn on your mic, or you can also tell me. So you have please 2-3 minutes, within 2-3 minutes, or you can take the 5 minute also. As soon as possible you just try to calculate and try to write your answer in the chat box. I am waiting. So before moving, Deepika, I am audible very clear? Because Murli not able to hear me very clearly, so I am asking to you. My audio is very clear? Please you can write in the chat box also, or you can turn on your mic also. Okay, that's fine, very very nice. And I think the slide is also visible. Whatever I am writing, that is everything is visible. If yes, please you just try to calculate. Okay. So I am waiting 2-3 minutes. I'll wait. You please just try to calculate the answer. So for calculating your actual discharge and velocity, you need to first calculate the this theoretical. After calculating the theoretical, then you are very easily you can calculate the discharge actual and this actual velocity, because the coefficient is given already. The coefficient of discharge as well as coefficient of velocity is also given. So definitely after calculating the theoretical, then just multiply with the coefficient of velocity and coefficient of discharge, you will get the actual one. So now let me just show you the answer. Okay, so as you know the formula for actual discharge as well as for your actual velocity. So already head you know, head is given. So from here very easily you can calculate the velocity, because everything you know, CV also know, G also know and head also know. So actual velocity you can calculate very easily from here. And for theoretical, as you know the discharge is what? The theoretical discharge is your theoretical velocity into area. Area is given already because pi by 4 into d square. Diameter is given. Diameter I think 100 mm, so you need to convert this in meter, then you calculate area. So as you can see here, the theoretical discharge is your this one. And after multiplying with CD, you will get actual discharge here. So very simple step. So here is the two answer here, that is 0.073 and 13.44. So 0.073, 13.44. So option D will be correct here. If this is A, so here option D will be correct. Remember please. And how you will calculate? Just very simple. The relationship here, discharge equal to area, velocity into area, as well as some, if you want to go for the actual one, you just multiply with your coefficients. Now let us move with the next question. So this question is not here relevant. Okay, so this question is very important for your exam point of view, final exam and PTEL point of view, as well as your competitive exam also. So which option actually, which number is defined as the square root of the inertia force to the surface tension force? Whether Mach number, Froude number, Reynolds number, as well as your Weber number. So which number is defined as the square root of inertia force? That is, here is the question. The square root of inertia force Fi divided by surface tension force F sigma L, right? Sigma here represent the surface tension. So whether this X known as Mach number, Froude number, Reynolds number, as well as your Weber number, which one? So the question is this, very simple question. So please first try to think on that and try to write your answer in the chat box. So you have 2 minutes for this question, then after I'll show you the answer. So please everyone. Okay, you are telling, oh, let me just, okay, you are telling the Weber number. Okay, fine. So, means according to you, the option D is correct. So, definitely, option D will be correct. Your definition of your Weber number is the ratio of square root ratio of your inertia force divided by surface tension. So, here a lot of number is there, the non-dimensional number. So please just I'll go one by one. Reynolds number is the ratio of your inertia force divided by viscous force, and the formula as you can see here. And the significance, what is significance, is very very important. Sometimes the question come from the significance. The flow in closed conduit, when the flow in the closed pipe, will use this Reynolds number. And the resistance experienced by submarines, airplanes, fully immersed bodies also will apply this. Then Froude number, here you can see the Froude number is the square root of your Fi divided by Fg. Fg here your the gravitational force, as you can see here, the gravitational force. And it is used for where the free surface is presented and the gravity force is predominant, such as a spillway, weir, open channel, wave in the ocean. The flow of jet from an orifice or nozzle will apply these things also. This is your Froude number. This application will be important when you will study the dimensional analysis chapter, and when you will apply something to make something from your prototype to model, then you will apply this type of non-dimensional number. The flow of, yes, we have covered this. Now let us move on the another one. Euler number is the ratio of square root ratio of Fi divided by Fp, that is pressure force. Use in the cavitation studies where the pressure force is predominant. Use in the closed pipe where the turbulence is fully developed, so that the viscous force are negligible. Remember please, we can apply this Euler number also. Now let us move on the Mach number. Mach number is Fi divided by elastic force. Fi means inertia force. Here it is the given. Fi inertia force, F is elastic force, F sigma is surface tension force. So it is used for where the fluid compressibility is important. Remember please, the launching of rocket, in the launching of rocket will use Mach number. Aeroplanes, projectile moving of the supersonic speed, underwater testing of torpedoes, and water hammer problems will use Mach number. Remember please. Now Weber number we will use in the capillary studies where the surface tension is predominant, capillary rise in the narrow passes, capillary movement of water in soil, capillary wave in the channel, and flow over weir for small heads will use the Weber number. So remember these things. Now let us move with the next question, very important. So the momentum correction factor beta for the streamline flow in pipe is generally, the momentum correction factor beta for the streamline flow in pipe is generally greater than 1.5, 1.01 to 1.07, 1.33. We are talking about here the momentum correction factor for a streamline flow. Streamline flow means what? Just think on that, then try to give the answer for this question. Very important question. So everyone please. Just think on that and try to give your answer. What is a streamline flow, and then after whether it is turbulent, laminar. Okay, you are telling 1.33. Yes, for laminar flow it is 1.33. Remember please. Here it is very important. These two line is very important. For turbulent flow 1.2, for laminar flow is 1.33. So remember please, for turbulent flow will be less compared to your laminar flow. Laminar. The kinetic energy correction factor is 2 for laminar. Yes. Oh, I think for here not written. For you just please try to find out the kinetic energy correction factor for turbulent also. Very important. So from here the direct question comes from these two, the, oh, three lines, 1, 2, 3 lines, or another one is the for kinetic energy correction factor for your turbulent. So remember please. I think in the gate previous year the question come from I think previous to previous year. So now let us discuss the next question. A plate at a distance of 1 mm from a move at 60 centimeter per second and require a force 2 Newton per unit area to maintain speed. Determine fluid viscosity between the plate. So you need to find here the fluid viscosity. As we are discussing the fluid dynamic here, but what I have did, I have collected some questions from your previous weeks also, so that you can, your revision will be very uh, very important, because the previous questions also very important for your final exam. That's why I am doing these things. So please just try to write your answer in the chat box. Everyone, please. Oh, okay. Deepika is telling option B. Okay. 0.33 into 10 raised to minus 3 Newton second per meter square. Okay. So here concept is this, once the plate, the distance between the plate is very less, that is 1 mm or 2 mm, so you can assume the velocity variation is linear. So from this concept very easily you can calculate. So let me just show you the answer. So here is the answer. Oh, your answer is this, 3.33. So hope somewhere you have a calculation mistake, you did 3.33. So option 3.33 into 10 raised to minus 3. This one. Option A is correct. So I think somewhere you have did mistake. So the your formula, whatever you have formula, tau is equal to du by dy. So once the plate is very very near, that is 1 mm, so this formula become, wait one minute, this formula become tau is equal to u velocity by y. So from here you can very easily calculate. The tau value is given already and the area already you know, and so from here you can calculate the shear stress, and u velocity is given, that is a 60 centimeter per second, you need to convert in the meter, so 0.6 meter per second, and y is already given 1 mm, so you need to convert in mm into meter. So from that definitely you are able to calculate very easily. Now let us move with the next question. If a body floating in a liquid turns back to its original position when give a small angular displacement, the body will be in stable equilibrium, natural equilibrium, unstable equilibrium, not in equilibrium. Very easy question. From your general mind, you can also tell the answer of this question. But this question is from your fluid static. The principle behind it, your the buoyancy concept here. So just you try to give the answer. Please just everyone write your answer. Okay, Deepika is telling option stable equilibrium, A option. Okay, good. Other student, please also you just try to write your answer. Then I'll show you the answer. So for each question I have the explanation. So please, once I'll upload the PDF, everyone please go one by one and try to read all the explanation for your future questions also. Okay. So yes, definitely a stable equilibrium will be the correct answer for this question. So now let us move. Here is the explanation is given for the conditions when the G and B is lie. So what is G and B? Once you will go with this, then you will definitely get it. Okay, now let us move with the next question. Yes, this is also very very important. So dimension of kinematic viscosity represented by, here we are talking about kinematic viscosity. Option A, L square T minus 1. Option B, L T minus 1. Option C, L minus 2 T, and option D, L minus 1 T. So which option will be correct? The kinematic viscosity we are talking about. So as you know, the dynamic viscosity is, okay, first you just try to write your answer, then I will discuss a little bit. If you not know, just you try to calculate. If you know the definition of dynamic kinematic viscosity, then very easily you can calculate. Okay, Deepika is telling option A, that is L2 minus T minus 1. Okay, fine. So please, another student, please also you just try to write your answer. Okay, L2 minus, you are telling same things. Okay, fine. So yes, definitely the L2 minus T. How you will calculate? You know the already formula. Your kinematic viscosity, dynamic viscosity divided by rho, and dynamic viscosity formula you can calculate from here, du by dy, and your tau is equal to force by area. So everything is I have break. So after the breakdown you can easily, the force, you know, force is mass into acceleration, so you know the unit of mass, acceleration, area, velocity, y, and once calculating the here the viscosity unit, then you will put here, and your rho is mass divided by volume, so you know the unit of volume and mass already, so definitely you will get the answer LT minus L2 T minus 1. Now this is again from your previous week. So absolute pressure is equal to atmospheric pressure plus gauge pressure, atmospheric pressure minus gauge pressure, vacuum pressure, oh I think video is off, the vacuum pressure plus gauge pressure, and the vacuum pressure minus gauge pressure. Which option will be correct? A, B, C and D. So please you just try to write your answer. We are talking about here the absolute pressure. Okay, you are telling option A. Murli is telling option A. Okay, fine. Okay, both you telling the option A. Yes, definitely. We are once we talk the absolute, then definitely atmospheric pressure plus gauge pressure will both consider. The definition is given here. What is vacuum pressure and what is gauge pressure, and everything is given here. So please go one by one. The all lines is very important for your exam. Now the another question is very important. Okay, let me just reduce the size. So the next question is, consider the following statement. First one is, pump in series operation allow the head to increase. Pump in series operation increase the flow rate. Pump in parallel operation increase the flow rate. Pump in parallel operation allow the head to increase. So which option will be correct? I have discussed lot about this series and parallel combination in the previous lecture. So once if you have gone through the video, uploaded video YouTube, so definitely you will able to give the answer. So you both please try to write your answer in the chat box. Okay, option B may be correct. Okay, means A and C. You are telling A and C, right? That is pump in series operation allow the head to increase, and C is the pump in parallel operation increase the flow rate. Okay. Okay, let me just, I am waiting for another response. Okay, you are telling option A, that is A. You both are telling option, that is the first one, pump in series operation allow the increase the head, and the Murli is telling option D also correct, the pump in parallel operation allow the head to increase. Okay. No, please remember these things. The pump in series, let us just try to think physically. We have the this type of pipe in the series connection pipe. So from here you can correlate, but here we are talking about the pump in series operation increase the flow rate. Definitely, let us suppose in the series operation, if you will here once pump is installed, here one pump is installed, here one pump is installed, so definitely it will increase. No, this is not the pump in the series operation allow the head increase. Definitely, once you will install the pump here, the pump have the more energy, then it will increase the head. Remember please these things. So here option A and C will be correct. And see how it will be correct. The pump in the parallel operation, the flow rate will be increased. Let us suppose if you have the lot of pump in the parallel operation, what will happen? This pump also give discharge, this pump, so definitely your final discharge will be the more. So here is the definition is given already. Definition, example, everything is written. Now, very important question. The velocity distribution in viscous fluid through a pipe is elliptical, hyperbolic, parabolic, circular. The velocity distribution of viscous fluid, we are talking about viscous fluid here. through a pipe, remember please, through a pipe. Which option will be correct? Okay, Deepika is telling option parabolic, that is C option. A, B, C and D, parabolic. Okay. Okay, after this question I'll take the 5 minute break, so you can also take, if you want. If you not take the break, then I'll show you the question, then you just try to solve within 5 minutes. Yes, definitely the parabolic will be the correct answer. Now let us, here is given the flow is whether if the flow is turbulent, flow is laminar, then how the velocity distribution will happen. If the flow is laminar, then the parabolic. If the flow is turbulent, then logarithmic. Here you can see. So we are talking about here the viscous, so definitely we are talking about the laminar thing. So this question, please you just try to calculate. After 5 minutes, I take the 5 minute break. Then after I'll discuss. So please you both try to calculate. Or if you want to take break, you can also take break. No issue. Okay, so you are telling the option A is correct, that is 0.58, A option. Okay, so the question is, okay, let me just discuss. Oil of a specific gravity 0.8 flow through a 0.2 meter diameter pipe under the pressure 100 kilonewton per meter square. If the datum is 5 meter below the center line of the pipe and the total energy with respect to the datum is 35 Newton meter per Newton, the discharge is what? And take G is equal to this. So here you need to calculate discharge. So for discharge, you know, first the formula is this for discharge. So here velocity is not given. So how you will proceed? So as you know, here the total energy is given. So you know the total energy formula as per the Bernoulli's equation. P by rho z plus V square by 2z plus Z. And the datum is below the center line, not above. So remember please. And here pressure is given already 100 kilonewton per meter square. Rho already know the oil specific gravity, so rho will be your 800 kg per meter cube. G value is given, and here from here you can calculate the velocity, and Z is already given 5. So after putting the everything you will get answer. Okay, so here answer is not written, the correct answer is not here, actually I have written. So let me just calculate. 35 is equal to 10 raised to 3 for kilonewton, and 1000 into 9.81, I'll take 10 just for calculation simplification. V square by 2 into 10 plus 5. So this will cancel out, here 100 will remain. So and 30 is equal to 100 plus V square by 20. So V square by 20 is equal to 70, and the V square is equal to 1400, and your V is equal to root under 1400. So it means, so 10 root 14, 10 root 14. So now area is, diameter is given here 2 meter. So pi by 4 into d square 0.2 square into, and 10 root 14. So this will give you the answer. Let me just calculate using my mobile. So hopefully answer will be correct. Your answer will be correct. So tau, that is pi divided by 4 into 0.04 into 10 into root 14. So I think I am doing the calculation mistake somewhere. So 10 into 14. No. 37.4 and point into 5 divided by 4 into 37.4. Oh, somewhere I am doing mistake, but the calculation will be like that. Where I am doing mistake? Oh, here I think the value is 100 given, not the 1000, so I have written here the 1000. So remember please, 35 is equal to 100 into, for kilo this will be the 330, and 1000 into 9.81, or you can take, I think here the 9.81 written, so that's why the answer will be, once you will solve the using the 9.81, then you will get the exact answer. And v square, from here you can calculate 2 into 9.81 plus 5. So from here when you will calculate the your v value, and after putting in this formula, area into discharge, area into velocity, and area pi by 4 into d square. Why I am putting 0.2? Because diameter is here given 0.2 square into velocity. So you will get whatever the answer. So after this calculation you will get one of the answer from here. Okay, let us move with the next question. Again, question is very important. So next question is, water jet of diameter 25 strike a smoother plate, flat plate, normal, and is about to be rest. The jet speed is 30 meter per second. Neglect the loss. And what is the force of the plate? What is the force on the plate? So here you need to calculate the force on the plate. So please everyone, in between I will calculate the answer for the previous question. So please everyone just calculate. So this was the 30 is equal to your 100 divided by 100, that is your 10. So this is 10 almost, plus v square by 20. So 20 is equal to v square by 20. So v is equal to 20, I think, meter per second. And discharge is equal to 20 velocity into area, pi by 4 into 0.2 square. Once you will calculate this, 20 into this will give you 0.04. So 4 will be cancel out, and here is 100 pi. So pi by 5. So how much? Pi divided by 5. 0.62 meter cube per second. Is there any answer? 0.62? No. So still, oh yes, because we have used this one 9.81 at the place of 9.81, so I have used the 10. So hopefully your answer will be this one, because it is coming around 0.6. 0.6. So yes, option A will be correct. So Deepika answer was correct. Okay, so this question. The next question is this. A water jet of diameter 25 mm strike a smoother flat plate normally and it about to be rest. The jet speed is 30 meter per second. Neglect losses. What is the force on the plate? So you please just try to solve and try to give your answer in the chat box. Okay, let me just show you the answer. So yes, 442 Newton. So here question was, let me just show you in the graphically. A water jet of diameter strike on a smooth flat plate normally. So normally means on 90 degree. Normally it is striking. This is the angle is 90 degree. Normally striking. So what is the force? So definitely your force will be here. It is formula is written. The force will be what? Rho a v square means rho a v into v means momentum into velocity. Momentum into velocity. mv. So from here you can very easily calculate. Your velocity is given 30 meter per second and the jet diameter 25. So area you can calculate the pi by 4 into 0.025 square. So from here you will calculate the area. Area will come out to 4.99 and rho you know already 1000 and velocity given 30. So 30 square will give you finally 442 Newton. So the next question is water flow steadily from a 0.10 meter to 0.20 meter diameter horizontal pipe discharge 0.02 meter cube per second. If P1, that is the pressure at point 1, that is at level of here, the pressure corresponding to this discharge, this diameter is 200 kilopascal at a small section, this one. Neglect the losses, find out the P2. P2 corresponding to the this section 0.2. So this is very important question. So please just try to calculate. Very important question. Both please just try to calculate and write your answer in the chat box. Okay, let me discuss. So here is, you have the two pipe, that is the one pipe with the varying diameter. So, and the horizontal pipe. So here no inclination, like that. You have the pipe. Here is diameter is 0.1, and here diameter is 0.2 meter. Here pressure is 200 kilopascal, and here pressure you need to calculate. So okay, everything is fine, and discharge is given already. Q is 0. So from here you can calculate V1, because area is given. Discharge is equal to area into velocity. So V1 and V2 you can calculate very easily. So you can apply the Bernoulli equation here. P1 by rho g plus V1 square by 2g plus z. So z here will be 0 because it is horizontal. So no need z. Then P2 by rho g plus V2 square by 2g. From here you know already P1, that is 200 kilopascal. So I'll put here in pascal, and is 1000, because water is flowing here, water is written, and G is your 10 I am taking here, plus V1, whatever you will get, the V1 square and 2Z, plus is equal to P2 you need to calculate, then again 1000 into 10 plus V2 whatever you will get into 2 into 9.81, or you can take the 10 also. So from here very easily you can calculate the P2 like that. So the calculation is like that. First you will calculate the V1, V2, then after you will get the V1 and V2. Definitely once your area is here, you can see the at V1 the velocity is very high, at V2 velocity is very less. Compared to, so okay, finally your answer will be 203 kilopascal. That is C option will be correct here. Now let us move with the next question. Next question is, a pitot static tube with water, so the stagnation static head difference is difference of 0.50 meter. If the pitot coefficient is C 0.98, the local velocity is what? 2.50, 3.07, 3.50, or 4.43. Which option will be correct for this question? Very important question. So please just think and try to write your answer in the chat box. Just read the question very carefully and try to write your answer. Okay, let me just show you the answer. So here the pitot tube concept. So in pitot tube, once you will calculate the velocity, the formula finally will come like that, 2g delta h. So C already given 0.29 and delta h is given in the question is 0.5 meter. So from here, once you will calculate, you will get 0.03, 3.07 meter per second. So remember please. Next question. A horizontal venturimeter has diameter 0.2 and D2 is 1, 0.1 and CD is 0.98. The difference manometer, the Hg, that is mercury and water, reads 0.25 meter of mercury. Find Q. So here you need to find out the Q and here the venturimeter is given. Remember please. So please just try to calculate. Very important question. Your final exam point of view or also the gate exam also you can expect such type of questions. Because in the previous year a lot of questions from this topic only, they were venturimeter and orifice meter. So please just try to calculate and write your answer in the chat box. I'm waiting the, for this question you can take the 5 minutes. So after 5 minutes I'll discuss. Okay, the question is based on your venturi meter. So let me just show you the answer. So here the difference is of manometer is given is 0.25. So the formula is this for your this discharge using the mercury. So how you will calculate this delta P? So delta P you can calculate rho of mercury minus rho of water into GH. So from here you can calculate. So once you will put, you will get the final answer rho G, and area you can calculate A1 and A2 because the diameter is given. So pi by 4 d1 square, pi by 4 into d2 square. So everything you know, and CD is given I think in the question. Yes, CD is given 0.98. The coefficient of discharge is given 0.98. So from here you can get the answer very easily. Now let us move with the next one. This formula you can write also in the another form. This one root 2 delta P divided by rho. Rho means water here. So once we will take the here, let us take the outside of the rho W. So once we will take the outside rho W, so rho Hg divided by rho W minus 1 divided by rho GH. So once we will put here, so 2 root 2 divided by rho Hg minus rho W minus 1 rho GH divided by rho. So rho will be cancelled out. So only remaining here 2GH. 2GH into rho Hg minus divided by rho minus 1. So this will be remain. So combinedly this we can tell the H, capital H. So you can write this formula 2GH capital H. So your capital H will be is equal to a small h into this rho Hg divided by rho W minus 1. So you can write formula like that also. So now let us move with the, but you remember like that because this is very important. Sometimes forget about this formula, what is the whether this h or with a small h. So whether for this reason you remember this formula is very important. So the next question, a sharp edge orifice of diameter 50 mm. Sharp edge orifice is given, is on a side of large stand. The head above the center of orifice is 0.2 meter. The h is 2.0 meter. The coefficient of discharge is 0.62. Compute Q. Here also you need to calculate the discharge. So again you need to apply here the orifice meter concept, orifice meter formula. So for this question you can take 5 minutes. I'll wait 5 minutes. Please just try to calculate. Then after I'll show. So here is the orifice meter. So orifice meter is also very important as compared to your venturi meter for exam point of view. So the formula for orifice meter is this. Discharge here you need to find out. So I think in the question what is given, sharp is orifice of diameter. The diameter of the orifice is given 50 mm on one side of the tank. Left side is the tank. On the side of the large tank. And above the center of the orifice is head is already given 0.20 2.0 meter, and the coefficient CD is given 0.62. So the question is like that. One tank is there, and in the tank one orifice here, a small orifice is. The orifice diameter is like T is equal to 50 mm. Now you need to calculate discharge. So discharge is equal to area into velocity. So what is velocity? Root 2 GH. How much head here at this level? So head is already given 2 meter. And CD, for actual discharge we need to multiply with the CD. So your CD is given 0.62. So your final, after the final calculation you will get CD, area and 2GH. So after final calculation you will get 7.6 into 10 raised to minus 3. That is this one. This option C will be correct for this question. Very important. Now let us move with the next one. So water flow Q is equal to 0.20 meter cube per second through a 100 mm pipe from point A to B. ZA is 10 meter, ZB is 30 meter, PA is 100 kilopascal and PB is 150 kilopascal. Head loss HF is given 6 meter. Same diameter, same velocity, head at A and B. Remember please, same diameter and same velocity head at A and B. Required pump head, you need to calculate here pump head. That will be difficult question. So with this question today we will conclude, but first we try to solve this question. So I think no one is still joined, so let me just discuss. So here Q is equal to 0.20 meter cube per second. Pipe diameter is given. Dia of pipe is 100 mm. And point A and B. Let us suppose you have the 2 point. The pipe is like that, 10 meter and this one is 30 meter. Like that. This is your 30 meter and this is your 10 meter. Like that, and diameter already given at both places. This is A and this is B. This is your ZB, this is datum, and this is your Z1, ZA. Now the PA pressure here is given 100 kilopascal and pressure at B is given 150 kilopascal. Head loss is also given. Due to the friction, your head loss is 6 meter in this pipe. Okay. The required pump head. So you need the pump head. So this is a final question. You need pump head need to calculate. So how you will calculate? So this is the overall final question, but how you will calculate? Let me just show you. This is your the Bernoulli's with pump. This question is from the application of your Bernoulli's equation. The application of Bernoulli's equation. So definitely your diameter will be the same. One thing here I want to also discuss. Here if the diameter is same, your V1 and here is V2. So V1 is equal to V2. So your from Bernoulli's the the formula of V square by 2Z will be cancelled out from both sides because the V1 is equal to V2. So only remaining is PA by, here is the gamma is equal to rho G, PA by rho Z plus ZA plus HP, that is the power required by pump minus head loss is equal to PB. And why we have written these things this side? Because think here, your pressure here is 100 kilopascal. You need pressure at B is how much? 150. So you want to go from 100 to 150. So you need here some extra pressure. In the at P you need some extra pressure, and you will get this pressure from pump. So pump head you will add in this side, and minus another one you need. If the loss is 6 meter, so definitely you will consider 6 meter this side only. Why? Because after including this your 6, that is let us assume if the HF was 0, then what will happen? So your pump need, let us suppose initially your pump is required the 56 head with the 6 meter head loss. If the head loss will not there, then what will happen? You need only 50 meter head using the pump. Just for example, 50 meter head. So you need less energy. You need less energy. Once the friction is there, then you need more energy. So that's why we have written this your horsepower, that is your power, the head due to the pump and loss due to the your pipe friction is this side. That is the, after calculating this one, because all this term in meter, after calculating in this term you will, why we are equating these things? Because this is at point B. So for reaching your water reaching from point A to point B, you have to maintain this much head here. So for this we need the extra pump here. So this is about the all. So let us put here. So PA. So let me just, here is putting. So PA is your hundred into 10 raised to 3 by rho Z. So 1000 into 10 to the power 10 rho Z plus V square by 2Z will be cancelled out. So here power required by pump. Power required by, or we can, yes, power required by pump is, that is head required by pump. So H pump I will write here, and head loss due to the your friction of pipe plus datum. Datum at ZA is equal to 10 is equal to, the head at B is 150 kilopascal divided by 10 the your row of water, the density of water, into G 10 plus ZB. ZB is 30. So this will be 3 will be cancelled out, 1010. So this is 45. and this side is cancel out. So here 10, 10 minus 6, 4, and this 14. 14 plus HP. So HP is equal to 45 minus 14. So this is your 1 and this is 3. So around 31. So we have used here the 10 at the place of 9.81. So once we will use the 9.81, you will get exact answer, that is 31.1. But here we are for the calculation simplification. Remember please, these things is very required when you will do without any the calculator, the calculation. So you should assume the approx the 9.81, the 10 for your fast calculation, otherwise you will take the more time in your final exam. So remember these things also. So option C will be correct here. So let me just check. Yes, so option C will be correct. So today we will conclude here. So the next class will be on next Tuesday, that is 26. So on 26 we will discuss about the lot of questions regarding this. So this was about the application of conservation of momentum and application of Bernoulli's equation. So I think next question is about the numerical solving week, the week number 5. So we'll solve the lot of numericals, lot of questions on the next week, next Tuesday. So next Tuesday is your 26. So thank you. Let me just close it.